Welcome to my video on solving multi-step inequalities. So the key concept is use the same skills as solving multi-step equations. So look at this first example. I didn't give a lot of room there, so we're not going to work it out, but we're going to go over the steps that we would use. So since there's no distributive and combining like terms on the same side, we would move the variable first. So move variable. And if I move the 2x, that would give me 6x is greater than or equal to 24. So then my next step would be to divide both sides by 6, and then I would get the inequality. So you would write the inequality. In both directions. And the reason being, one, it could be multiple choice, and they might have put the answer that maybe you didn't write, so you could read it backwards. Also, if you're graphing, you always want to read it from the letters, so if the letter is on the right side, you want to read it backwards so that the variable ends up on the left side. So we're going to practice writing the inequality in both directions when we do the examples on this page. So let's look at the first example. The opposite of division is multiplication, so we're going to multiply both sides by 4. The 4's are going to cancel because I'm using the multiplicative inverse property. And 4 times 4x is 16x is less than negative 10 plus 6x. Now I'm going to move the variable. I'm going to move the 6x over by subtracting 6x. What's going to happen to the 6x's? Good, they're going to cancel. And 16x minus 6x is 10x is less than negative 10. Now I have one more step. The opposite of multiplication is division. So we're going to divide both sides by 10. 10 divided by 10 is a 1 in disguise. Bring down your x, bring down your symbol. Negative 10 divided by 10 is negative 1. Now we're also going to write it the other way in case you solved this and you didn't see this answer in multiple choice. So read it backwards. Negative 1 is greater than x. Now what I want you to notice is when you write it backwards, notice the symbol flips around. Okay, example number 2. I have a negative 2 that I'm going to distribute to both parts. Negative 2 times x is negative 2x. Now this part you have to be careful. Negative 2 times negative 1 is positive 2, so write plus 2 is less than or equal to negative 3x plus 7. So if I have distributive, I have to make sure I do that first. Now I don't have like terms on this side to combine or on this side to combine, so now I'm going to move my variable. And when I move the variable over, now I'm going to combine like terms. Negative 3x plus 3x cancels. Negative 2x plus 3x is 1x, so it's a 1 in disguise. Bring down the plus 2, less than or equal to 7. Now I'm still not done. Circle the variable and draw your t. The opposite of adding 2 would be subtracting 2. 2 minus 2 is 0. Cancel them out. Bring down the x, bring down the symbol, and 7 minus 2 is 5. So x is less than or equal to 5, or if I read it backwards, 5 is greater than or equal to x. So notice once again, when I read it backwards, the symbol flipped around. Okay, let's look at the next set of examples. And the key concept is when dividing or multiplying by a negative as your last step, flip the direction of your inequality symbol. So don't automatically flip it when you see a negative variable, because sometimes you might move the negative variable and turn it into a positive. So let's look at our first step. We don't have distributive or combining like terms on the left side or the right side, so now we're going to move the variable. So write move variables. And we're going to do that by subtracting 2x. Now I know I've said previously, I always like to move the smaller value, and I will do that at some point, but I want to show you that it can be done even if I move the larger value. So 2x minus 2x is 0. Now we're going to bring down this, so negative 8 minus 2 is negative 10x. Bring down the symbol, and bring down the negative 30. Now the next step is going to be to divide. So we're going to divide both sides by negative 10. Negative 10 divided by negative 10 is a 1 in disguise. Bring down your x. Flip the symbol, because we're dividing both sides by a negative, and negative 30 divided by negative 10 is positive 3. So we flip the inequality here. And then our last step is going to be write both directions. So if we read this backwards, it would be 3 is greater than or equal to x. Okay, let's look at the next example. And I'm going to move this up a little bit. Okay, we have 5x minus 1 is greater than or equal to 7x plus 9. Now this time, okay, I'm going to avoid the negative and I'm going to move the smaller value. Okay, 5x minus 5x is 0. Now remember, there's a minus 1 here, so it's negative 1. It's greater than or equal to, what's 7x minus 5x? 2x. And then bring down the plus 9. Now circle your variable and draw your t. The opposite of adding 9 would be subtracting 9. 9 minus 9 is 0. Negative 1 minus 9 is negative 10. It's greater than or equal to 2x. And don't forget to divide by 2. And this is really important. 2 divided by 2 is 1 in disguise. So this is important. Bring it straight down. Negative 5 is greater than or equal to x. Or x is less than or equal to negative 5. Now, some of you are probably wondering, well, what if we move the 7x? If we move the 7x over, we would have got negative 2x. Then we would have had to remember to flip the sign, so it would have turned to less than or equal to. And look what my final answer ended up, less than or equal to. So when you read it backwards, okay, when the variable's on the right, it does in fact flip it around. Okay, let's look at the last example on this page. So notice I have like terms on this side, but they're not next to each other, so I'm going to use the commutative property and get them next to each other. Now I'm going to combine like terms on the same side, and since they're on the same side, I'm not using the inverse, so 2x minus 5x is negative 3x, plus 7 is greater than 2x minus 8. Okay, now I would normally move the negative 3x, but I'm just going to move this one so we can practice with negatives. So 2x minus 2x is 0. Negative 3x minus 2x is negative 5x plus 7 is greater than negative 8. Circle your variable and draw your t. The opposite of adding 7 would be subtracting 7. 7 minus 7 is 0. So we have negative 5x is greater than negative 15. Remember, we have to divide both sides by a negative. Ding, ding, ding. You have to flip the symbol. So x is less than 3. Or, read it backwards, 3 is greater than x. Okay, and remember, we haven't talked about it yet today, but remember there's two checks. We can plug in the 3 and see if both sides equal the same thing. And then we can also plug in something less than 3 and see if this is a true statement. So make sure, even though we haven't gone over the check today, that you are still checking these, just like we did when we did 1 and 2 step. So graphing and finding the solutions. It says use an open circle for less than or greater than, and use a closed circle for less than or equal to and greater than or equal to. So I don't see distributive or like terms on the same side, so I'm going to do the first step, which is move the variable. So let's do that. I'm going to add 2y to both sides. And negative 2y plus 2y is 0. 3y plus 2y is 5y. Minus 21 is greater than 4. So the second step I did was add. And I'm going to do it right now. So circle the variable and draw your t. We're adding 21 to both sides. 21's cancel. We have 5y is greater than 25. Now my next step is going to be to divide by 5. 5 divided by 5 is 1 in disguise, and y is greater than 5. Now, if my variable is on the left side, I can shade the way the arrow is pointing. So variable is greater than number. That checks. We want that to work. Because if the variable is on the left, I can shade the way the arrow is pointing. So I'm going to shade greater than 5. So I'm going to shade to the right of the 5. Open or closed circle. Good. It's going to be an open circle. And then I'm going to draw the arrow. So we're going to do an open circle on 5. And we're going to draw the arrow. And remember, the open circle means that 5 is not one of the solutions. So it says, which are the possible solutions? So I'm looking for ones that are greater than 5. Well, I can't be 5 because 5 is not greater than 5, so it's got to be 6 and 15. So circle these two. Okay, we have 2 more examples to look at. Number 1. We have negative 18x is less than negative x minus 34. I don't see a number here, so I can put a 1. And then I'm going to move the variable. I'm going to make things easier, so I just have one less step here. So I'm going to move that over. And I know I'm going to get negative, and that's okay. Negative 18x plus 1x is negative 17x. is less than negative 34. Then we have the opposite of multiplication, which is division. So we're going to divide both sides by negative 17. Negative 17 divided by negative 17 is a 1 in disguise. Bring down your x. Bring down your symbol. And we have to flip the symbol because we divided both sides by negative. Negative 34 divided by negative 17 is positive 2. So x is greater than 2. Okay, I didn't rewrite it the other way because for graphing purposes, I have the variable on the left, so I can just write x is greater than 2. Okay, open or closed. I want open, and I'm going to shade this way. Now, if the variable was on the right side, then I would probably want to read it backwards so that I could rewrite it and shade the way the arrow was pointing. So I'm looking for solutions that are greater than 2. And I see 5 and 10. Okay, let's look at the last example, number 2. We're going to distribute the 2 to both parts. So that will give us 6x plus 2 is greater than or equal to 8x plus 2. Okay, now this time, instead of getting a negative variable, I'm going to keep the variable positive, and we'll see what happens. 6x minus 6x is 0. Bring down the 2. 8x minus 6x is 2x plus 2. Circle the variable and draw your t. The opposite of adding 2 would be subtracting 2. 2 minus 2 is 0, and 2 minus 2 is 0. Remember, when everything wipes out on one side, I need to replace it with a 0. So I need to put a 0 there. I'm not putting a 0 on this side because I have something else there. I have a 2x. Now the opposite of multiplication is division. And we get 0 is greater than or equal to x. Now notice my variable's on the right, so we can read it backwards. So I can shade the way the arrow is pointing. X is less than or equal to 0. Box those in. Open, close, open circle or closed circle. Good, closed. And we're going to shade less than or equal to 0. So since I have the variable on the left there, I can shade the way the arrow is pointing. But only if the variable's on the left. So I want all the answers less than or equal to 0. It's these 4. Now notice I picked 0 this time because it's less than or equal to 0. So when it's less than or equal to or greater than or equal to, then I can pick this number. That concludes our notes on solving multi-step inequalities. I hope you have a great day.